is correct. They are congruent as two right um, angles. And we have here O. You see, in both triangles we have O. So O, every angle is congruent to itself. So angle at O congruent to angle at O. So these two triangles have two angles which are congruent. Therefore, these two triangles, which are OMP and triangle OPT, have two congruent triangles. Angles. Hence, similar. And that's it. So the triangles, now just having a look at this, triangles, this and let's say this triangle here are similar. So their corresponding angles have the same measure, and from that similarity we can conclude immediately that this angle here is indeed the same as this angle here by the similarity. But that angle is then 1/2 of PTS. So we can write just in more details, which might be obvious. So OPT is congruent to PTO, which is congruent to 1/2 angle PTS. That means 2 OPT equals or is congruent to PTS. That means the measure of, so 2 OPT is the same as measure of PTS. And that's what we have proved. So you can have a look again, you can pause the video and go through all the details carefully so that you know each step and understand. And also understand what exactly we are using at this step. Okay, now question number 2. Get a chance. Right. Yeah. Okay. So question number 2. We have a similar situation as before, and I have already written the solution out, and I will just go through the solution with you so that you know, understand the steps. So OP equals to R, where R is the radius of this situation here, and we need to prove that OTS is same as OST, which is 30 degrees. So what we actually need to prove is that, for example, angle OTS equals 30 degrees, or we can also prove that the angle OTQ is 30 degrees. Why? Because those two are the same angles. So if you have, for example, something like this is O, this is just a matter of clarification, and you have S. And this angle here, so these two angles are same, because S is on the ray which starts from T. There are many ways, again, or not only the one way that to prove this. And some ideas we already deployed in the previous task. That's the reason why I have chosen to go and to solve these two problems one after another. And the situation is, if you compare even the graphs and the tasks, they have actually almost the same image here. Just copy. The difference here is, of course, that OP, which is this line, is 2R. But what is R? R is radius. And if we look at this image here, I'll just this space. If you look at this image here, this says nothing else but OP equals 2 times OT, or if we need anywhere, this also 1/2 OP is the same as OT, which is the same as OS, because they are radii of one and the same circle. Some facts that we know is, again, that these two segments are congruent, these two segments are congruent, and also that these two angles are congruent, these two angles are congruent, and so on. And from previous task, if we need, we can use this also, that the same colored angles have the same size in this image. One way to tackle this problem is thoroughly using trigonometry. And the very, very basic trigonometry here deployed is being used. So how to do that? If we look at the triangle, again, the fundamental property of the tangent is that here is a right angle. Just use this. So this here is a right angle. Now, whenever we have a right angle, we can invite trigonometry. And also we know that OP is 2OT or 2OS. So I will just again remove this so that we have more space. So if we use trigonometry here, and we only need one, which is sine, applied on this here triangle, we would like to know, of course, how much is P, or the angle at P. So sine of angle at P is opposite, which is OT, over hypotenuse, which is OP. If we look here carefully, the answer is actually here. I'll just make it easier to see. But we have this relation here. Now we can apply it here. So OT remains, but OP is 2 times OT. OT and OT are cancelled, so that is 1/2. So that means that sine of P is 1/2. And this is only possible when P is 30 degrees. This is basic trigonometry, which you are assumed to know when you reach this level of geometry. So this is what I've written. This is another way, or another strategy, which I will just present, and it has a small task which you can then investigate. We have sometimes triangles with specific properties. Those triangles are used and encountered in mathematics. Here, for example, we can use Pythagorean theorem again applied on the triangle OPT. And having that in mind, we can call the OT as X, and then we know by the fact this is 2X. And we will find the expression in terms of X for TP using the Pythagorean theorem. So TP squared plus OT squared is OP squared. Now OT we decided to call as X squared. OP squared will be then 2X, everything squared from here. And now it's just a matter of a calculation. So we have TP squared equals 3X squared, and TP is then square root of 3x squared, which is square root of 3 times x. And indeed, we can, there is yet another task. So this is like the development. Here we have finished our task. So this is what we wanted to prove. So we are done. Why? Because there is a theorem saying that if we have a triangle with the sides x, 2x, and square root 3 times x, this is 30, 90, 60 triangle. And that we can prove. So this is just like development using law of sines, which is again trigonometry. We can see that in this case, if we have the sides, I'm inviting you as a further task to prove that using sine theorem, for example, or any other way. If we have these sides in a triangle, then that will be, and by the way, 2x is hypotenuse. So the longest side will be 2x, which is again obvious because 2 is greater than square root of 3. So if this is x, this is 2x, and this is square root 3 of x. Then here is 90, here is 30, and here is 60. So you can prove that using law of sines or any other theorem or any other way that you want. So indeed we have proven that angle OTS, which is this angle here, is 30 degrees, and also OST will be 30 degrees because that's an isosceles triangle which has always angles on the base